Padova, Italy. He will be talking to us about enhancing clinical study analysis through federated learning, a systematic review using GPT and LLM.
Okay, good morning. Okay, thank you. I'm Zirinalani, a PhD student at the University of Padova, the School of Translation and Specialistic Medicine, in the unit of Biostatistics, Clinical Epidemiology and Public Health. My tutor is Professor Dario Grigori and Dr. Corrado Nanga and Honoria Hokagani. Before going to just present some works of Fencing student, I want to ask you how many of you are from medical school? Just I want to focus on at the end on collaboration, so I want to know how many of you are from medical schools. So many of you are from, I think, from the computational. So I want to make fast, and at the end, I want to talk something about some collaborations that we want for the future world. Today, I don't know why. Okay, great. I don't want to go into detail because some parties already presented yesterday by Professor Onip. I don't know if I pronounced it wrongly. In this work, we have used some importance of clinical study and how we can work it with parallel computation using some infrastructures based on HPC, high-performing computing. Then we focused to do some systematic reviews from different databases based on which focuses on federated learning, which is often very fantastic nowadays for some clinical studies. I just present some what to get from this work. Federated learning is for that. Is a machine learning approach that allows multiple situations to collaborate, and model training is often used to sharing the data without just sharing, keeping privacy privacy of the patients, and not the data is not sharing to others. And the other part is GPT models. These GPT models are generative pre-trained models like OpenAI from OpenAI that process and generates some human-like texts. Then LLM is also, we are going to use it, but I don't want to go to the detail of about large language models. Then there are some challenges often in clinical studies that I said now about data privacy concerns and limited data sharing and collaborations. So this federated learning is very, very important because of some advantages like this, ensuring patient data privacy and facilitate multi-center data collaborations. And also from the trainings of the models, there will be some improved models. Just to say something about the GPC, because yesterday a lot of our colleges are talking about this. In Italy, the first high-performing computing on these issues already installed in Bologna, which is more than, I think, 5,000 computers are working together. And in my university, in University of Padova, Capiri is already installed and they are going to use it. And me and my units are already working on it for our unit, just for some works to use for some data. And as an example, me and some other students just work on cost of myocardial infarction patients in the hospitals of the whole Italy from two units. So in the first part, we all tried with 4 centers, and this is actually done. And then later we working with 8 centers in Italy. And next we are going to work on 22 centers, data from 22 centers. So to just analysis cost of myocardial infarction. So how this is applied, or both HPC and federated learning is can be applied in the clinical data. Let's come to what is GPT to come to my related title. So GPT is, as you know, it is OpenAI large language model that already works with pre-training, fine-tuning, and text generation. So we have some capabilities, so let's jump over this. Our objective is just to use federated methodology to use for ChatGPT for systematic review. We use data methods from database from image, PubMed, Corpus, and Web of Science, and also other in this work. ChatGPT 4.0 is used for as a GPT model. It is costly, and our unit is paying that. For that, then we have this much of data. Imagine if we have more than 50,000 for each database. We need some procedures for coding with my professor for data code and regularizations to just bring this and the selection. Then as the results, I just we have done some started information, and some state designs are made for federated learning and statistical methods that we are going to use or extract from the publications. Then we checked federability of the clinical health data and how collaboration can be made between clinicians, statisticians, and data scientists to bring some new thing for analysis, and the role of GPT and LLM models. Then we have future collaboration. That this is what I want to talk now. Previously, we have made some workshop last June 2024, and with this workshop is collected a lot of professors from Africa came to Padova last June. I and my college working on that, and some professors from Africa came to Padova, and they already presented on this because our unit wants to make some collaboration with Africa. And Professor Dario is a coordinator of our school, and he has more than 40 students from Latin America, Argentina, Brazil, Honduras, and Colombia. So we want to make that one in Africa. So we have this chance in the future. This is some picture when after the end of the workshop, a dinner invitation at the end, and this is Professor Dario. This is my postdoc, and he's data scientist. And I want to thank them, University of Padova, unit of our unit, Biostatistics and Clinical Epidemiology, our laboratory, Artificial Intelligence for Medical Science, yes, where I'm working. So, thank you. These are our members.
Okay. Thank you very much. If you are interested in collaborating with him, I think you can see him afterward. So the next speaker is Peredi HAWASSA. Peredi HAWASSA, Cystomyces drug development, a computational approach. So he's from. This was the one that didn't respond. Yeah. No, it's not this one. Let's go back. This is the BPS office. Okay.
Greetings, everybody. My name is. Greetings, everybody. My name is Peredi HAWASSA. I'm going to do a brief presentation on schistosomiasis, a drug development. I'm going to do a computational approach on this drug development. That is going to be my outline for this presentation. So quickly we're going to go through this. Time is not a lot. So first, the introduction will be to understand why computational methods are important for the development of drugs. I'm going to use sort of think about a battle that keeps happening between your body. So you have your white blood cells and you have all the pathogens that are trying to come and defeat them actually and take over your body. So in this regard, we need to strengthen our white blood cells, and we need sometimes drugs to help us do this. But sometimes we have so many ideas of how to defeat the enemy in this context, and we need to narrow down these ways in which we're able to defeat these pathogens so that we can effectively do this process. So in this present study, I'm going to look at the effect of several antischistomal drug candidates, and PCQ, that will be the control, the glycocalcone A, licarin, ammonin, and P96. We are going to see their structures a little bit later. So this work was presented at the African Biogenomics 2023. This was a call for African solutions towards global problems, especially dealing with NTDs, as schistosomiasis is one of the NTDs, neglected tropical diseases. So, first of all, it will be quite important to realize first what schistosomiasis is. So this is the enemy, and to understand how he gets into to attack mode, we have to understand how he gets here. So first of all, we will have that the eggs will be released into freshwater bodies through either infected feces or urine. They will hatch in these water bodies, and then they will be able to penetrate the snail tissues in form of metacardia. Then the metacardia will also develop and form sporocysts inside the snail, and then the sporocysts are going to be released, and then they are going to penetrate the sacarias are able to penetrate the skin, and now the whole circular, the whole motion continues to happen through the human body now. And this will, the parasite will be now inside the bloodstream, will go towards the liver, will go into the bowels, and also the bladder, and get released back. And this whole cycle is complete. And current treatment methods are actually PZQ. We have to understand first how we are able to, what are the current methods in which we are actually bombarding the enemy at this point. And the main one right now is PZQ, but it has several challenges that instigates us to develop other drugs. So, firstly, there's quite a lot of drug resistance because the enemy you keep bombarding the enemy with the same artillery. After a while, they realize, okay, we can have bulletproof vests, and now this does not work. Nextly, we have the people who are using this artillery keep complaining that this is not working, this is not good for us. Why? So PZQ shows high lack of patient compliance, especially due to the taste of the drug being quite bitter and also quite contraindicative side effects such as hematoxia and the rest. Hematoxia is actually a lot of blood in the urine during treatment. So also we are also to see that it is quite ineffective against immature forms of schistosomal species, and it actually works on schistosomal species that are adult worms. So as they are in juvenile worms or the rest, the drugs won't work. Also, we also to see that praziquantel does not provide a lot of protection against reinfection. So when the enemy goes away, when he comes back, he finds you still vulnerable and there's no defenses left. And also, there's a lot of global parasite burden. We are talking about schistosomiasis affecting 100 million people who are infected and 700 million people who are actually prone to infections. So we need to find ways to combat this. So in understanding the enemy and the way he's coming towards, bringing the fight towards us, we have to identify the target. This was the target identified as the schistosomal glucose transport protein, and number 4. So why this target? Since it is present all over the parasite. Also, it's present in all the species of schistosomia, the schistosomes, and also it is responsible for much of the glucose uptake from the host, and also manages the growth of the schistosome. So the ligands that were used in this study included hamine from the cereal root, lipocalcone A from the licorice roots, and licarin from the cellulose kinesis, and also P96 from the modified form of PZQ, where the cyclohexane is replaced by a cyclopentane. So the methodology in protein for docking. So since it is not available, we take the closest protein next to it, and we do some homology modeling on it. And after that, we check for the stability and overall quality of the protein that we model. After that, we go to the selection and those processes. And all this is with the objective of attaining a minimum of 32 conformations for each ligand with the tox and ADMET screening by the use of a peak tool. And the parameters are mostly just to make sure that we are able to follow the Lipinski's rule of 5. Does it conform to that? Next, we are going to do a grid generation and molecular docking of the HTTP4 with respect to the ligands that we're going to use. The choice of software was Autodox version 4, and that was the process that we used to do the docking process. And for the docking analysis, we have Protein Plus and LibPlot Plus. These were used to generate the 3D and the 2D images to show how the docking happened. So in results and discussions, we can see that these are the figures depicting the raw and prepared HTTP4 proteins. So we can see the addition of hydrogen bonds, and also what we are trying to do is enhancing the stability of the protein, followed by structural optimizations and energy minimizations. The next will be to look at the quality of the protein that we have created. This is done by the use of our Marchand plot, and we can see that the red regions have more black dots. That is what we would like to expect. Those are more amino acids in areas that we want them to be. The white areas are the ones we don't want to see amino acids in, and we can see that we have a 0.2% there. So this is an acceptable modeling of the protein. So the docking studies, first we'll talk about the inhibition constant versus the ligands. This is to show how strongly a ligand binds to the protein. and it specifically represents the LC50, how much of the compound do we need to actually reduce the activity of the protein by 50%. So we can see the performances of the different ligands in this. Next will be the binding energy, which is just the same as we do in a lot of computational studies. It shows the change of energy that accompanies the formation of a complex between the ligand and the protein target. So a more negative binding energy implies that we have a tighter and more stable interaction. So we want to see from our ligands that we use during the docking, which has the less or the more negative binding energies. So lastly, it will be the root mean square difference. This just gives how closely the predicted position of our ligands and complexes are in actual correspondence to our experimental data. Finally, these are images just to show the amount or the types of interactions. So we are looking for more hydrogen bonds, we are looking for pi stacking. This shows that actually there was a lot of good binding between this. So just as I quickly conclude, so the AGMT studies, this shows the absorption, distribution, metabolism, excretion and toxicity of the selected ligands. And you can see the glycocalcone and licarin, we have reasonable weights, low dipole moments, and they follow the Spencer rules of 5 and the rule of 3. And the human oral absorption scores are actually quite good. But when we come to PZQ, P96, and harmony, we actually see low human oral absorptions. And these are actually P96, since it is PZQ, just a small adjustment on the PZQ structure, we see that it inherits a lot of those limitations. Harmony behaves quite poorly. And conclusion, so glycocalcone A was shown to be quite promising candidates, and actually it is all could be found in nature, being a chalconate group, and it's also used as an anti-malarial, known as a very good anti-malarial, anti-cancer and antibacterial. So future research involves the introduction of this into wet lab trials. It is currently being done, and this work was published a few months ago in the Journal of Drug Development. So other related studies. In continuous to this, we also did a study on electrochlorination systems to be able to improve the water quality, especially in hard hit areas and hardship areas. This work was presented in Usonomiya, Japan, and we currently have partnerships with...
Okay, thank you very much. Okay, please you bear with me to invite one more speaker for this session. That will be Dr. Eden Gimaya Tefara. She'll be talking to us about integration of AI in predicting the intersection between climate change and malaria transmission for public health decisions in Ethiopia. Am I right?
Yeah.
Okay, so which is your presentation?
I become the last presenter, so that was the least. Okay, thank you, Professor. Before I commence my presentation, I would like to express my gratitude for the organizing committee and HAWASSA University. So your contributions are not only shaping this conference, but also envisioned our entire field. So my name is Eden Gimaya, I'm from Ambo University. So my topic will be integration of artificial intelligence in predicting the intersection between climate change and malaria transmission for public health decisions. As we know, this climate change is becoming the world profound and widespread issues. So it affects the world. So we have seen flooding, droughts all over the world, and also recently there is a higher number of neonatal deaths due to this preventable malaria disease. So this is Ambo University. So it was established in 1947, almost in 2022. The university celebrated its 75 years of anniversary, which is historical, one of the historical universities in Ethiopia. The university ran almost 78 postgraduate, including 10 PhD programs and 71 undergraduate programs. This is my presentation content. So, as an introduction, so malaria caused by the parasites of Plasmodium family, which is transmitted by Anopheles mosquito. Particularly, Plasmodium falciparum is the most prevalent type in sub-Saharan Africa. So still the malaria become a serious global health challenges. In 2022, the World Health Organization report, there were an estimated 247 million malaria cases, clinical malaria cases, and 690,000 cases globally. And Africa region continue to be affected disproportionately high burden of malaria disease. And from the statistics, 78% of children under 5 are affected by malaria. So when it comes to the incidence in Ethiopia, there are about 5 million people affected by malaria in Ethiopia, and around 75 million people are at risk of contracting this disease. Recently, there is a new species, Anopheles stephensis. It's an emerging global dominant species in Africa and also including Ethiopia. And therefore, we need such kind of AI technologies to prevent and manage this malaria burdens. And also, we need cutting-edge research approach to fight against these invasive Anopheles stephensis mosquitoes. So the Ethiopian government has made a remarkable achievements in controlling and prevention of malaria by mass distribution of mosquito bait nets and indoor spreading of insecticide spreading and effective malaria drugs. And also the community health workers play a significant role in preventing malaria. And this is a community health worker. They are, so what will be the application? How this machine learning applied? So the first one is vector identifications. AI, especially the convolution neural network, can be trained to identify which species of malaria through vector identification. So we do have real-time data. From the environmental data, we can integrate this environmental or climate data with the patient data for predictions of malaria. We do have AI-driven predictive modeling, as you know. You are more familiar than me, the clinician one. So we could have integrate and collaborate to make significant changes. So we have geospatial modeling, which can be integrated with GIS to mapping high-risk malaria burden area. So in terms of accuracy and efficiency, we can see these AI models. We can use different techniques like data utilizations. So AI systems can generate large volume of data to predict malaria. We do have pattern recognitions. Recently, this artificial intelligence, particularly deep learning and machine learning, they are in identifying complex pattern recognitions. So AI models is its adaptability in nature which provides in improving its precision or accuracy. So the other ones, in terms of efficiency, we have AI model can automate data processing and analyzing, which reduce significant time. And therefore, by providing these accurate predictions of malaria, we can use our resource efficiently through targeted spraying of this anti-malaria insecticide, returnants, and the like. So in the epidemiology, the other one is its scalability. We use these AI models recently. So when we comes to the case studies in Africa, in Uganda, research indicate that
You have 3 minutes.
okay, finalizing in Uganda, the researchers they uses the health data with environmental data. They combine those data to predict malaria, and the model efficiently predict the malaria in rural Uganda. In Zambia also they use satellite data. And in Kenya, the researchers they use mobile applications for the users to record their malaria symptoms. Then they can integrate with real-time predictions. So when there is also a challenge in the application of AI in healthcare in Ethiopia due to there is low data. There is also lack of comprehensive data in the health institutions. In education infrastructure, we know there is resource constraints, and also we have resistance for the new technologies. So these factors are tackles in the applications of AI in the healthcare. We are using hard copy for treating for recording the patient data, which hinders using the digital one. So for recommendation and future directions, by focusing on forecast predictors and leveraging the machine learning algorithms, it's important for decision making tools. So implementation strategy, AI solution in Ethiopia, we have to use this comprehensive data, environmental data, patient data, and malaria population dynamics data. So we have to build data infrastructures, data centers. We lack data centers. And there is no ethical policies. So we have to make ethical. And the last one, we have to collaborate and joint research programs to enhance and leverage AI in the medical and clinical scenario.
Okay, thank you.